Hey guys, Mr. Roden here. Sorry I'm not here with you today, but I'm here with you in video. And so let's not waste time. Let's learn something new today. Sound good? All right. So today we are. Let me hit my turn to my window here, and our learning target is I can use properties of special parallelograms to solve problems. So we've been doing parallelograms. Now we're going to move on to some of the special parallelograms. We're going to do a warm up, and then we're going to take some notes on the learning target, and then I'm going to assign some delta math for you, and I'll tell you what that is in a minute. Okay, here we go. So we have a warm up here, and it says preserve the following. Preserve in the problem solving. Okay, the plan for a city park shows that the park is a quadrilateral with straight paths along the diagonals. For the what values of the variables is the park a parallelogram? In this case, what are the lengths of the paths? Okay, so on this one, what we were going to use is, remember what we said, if a quadrilateral is a parallelogram, if and only if the diagonals bisect each other. So that would mean that 5x plus 2y equals 2x plus 4y. And that would also mean, I'll do that one in red. That would also mean that 12y plus 50 equals 16y minus 10. So your job right now is to go ahead and solve these two equations. Pause, Mr. Roden. Solve these two equations. Just do it in your notebook and see if you get them right. Go ahead. Hey, welcome back. All right, so let's see here. I'm going to just solve. Looks like the purple equation is a good one to start with. So I'm going to go ahead and put a fairness bar down the middle of the purple equation. Let's see here. I'm going to subtract 2x's from both sides. Subtract 2x's from both sides. Oh, hold on for a second, guys. I got an x and a y. If I'm looking at this right, I've got x's and y's in this equation right here. So what I'm going to do is actually on the other red equation, I didn't see that right away. On that red equation right there, guys, I've got just y. So I'm going to actually solve the red equation. And once I know y, then I can solve for x, okay? Because I think I just have y's in the second red equation, the second equation, okay? So in this case, I'll go ahead and subtract 12y's from both sides. Subtract 12y's from both sides. Goodness sakes, Mr. Roden. Erase that. Sorry about that. Subtract 12y's from both sides. And so those y's cancel. I get 50 equals, well, 16 minus 12y is 4y minus 10. And then we'll, let's see here, we'll add 10 to both sides. So we get 60 equals 4y, right? And then we'll divide both sides by 4. Both sides by 4. And we get, okay, we'll go over here, 60 divided by 4. 4 goes into 6 one time. 4 is the remainder of 2. 4 goes into 25 times. So 15. So I get y equals 15. All right, now that I know y equals 15, I can go through and put 15 in for this y over here and solve for x. So now in this purple equation, I can say 5x plus 2 times 15 equals 2x plus 4 times 15. Just replacing a 15 with the y. And then let's see here. So we get 5x plus 30, because 2 times 15 is 30, equals 2x plus 4 times 15 is 60. And then I'll subtract 2 x's from both sides. So I get 3x plus 30 equals 60. Then I'll subtract 30 from both sides. So I'll get 3x equals 30. And then I'll get this dividing by 3 on both sides gives me x equals 10. So now I have x equals 10 and x equals y equals 15. So let's figure out what this distance from r to v is. And once we know that, it'll be pretty easy because v to t will be the same because they bisect each other. So we know that rt and tv are equal to, we'll just go ahead and put those numbers in. So let's see here. We'll just put let's see here. X is 10 and y is 15. So we'll say 5 times 10 plus 2 times 15, right? Well, 5 times 10 is 50. 2 times 15 is 30. 30 plus 15, 30 plus 30, excuse me, 50 plus 30 is equal to 80. So we know that RT and TV are equal to 80. Now let's let's find SV and let's find UV. So SV and UV are equal to, I'll just put in let's see here, I'll put in 16 times y. Well, y in this case is 15 minus 10. Well, 15 times 16. So if I take 15 and I multiply it by 16, I get 240. So that gives me 240 minus 10, which gives me 230. So SV and UV are 230. And I'm done. So hopefully you were able to get those by yourselves. Hopefully my math is okay. Sometimes I make little mistakes in my math. So make sure, I'm sure you guys will tell me about it when I get back that my math was wrong if I did something wrong. If not, I'm good to go. All right. So today we're going to talk about special parallelograms, okay? Now, remember, these special parallelograms, the first thing I want to mention about before we get into these special parallelograms is their parallelograms, okay? So everything that's true about a parallelogram is true about a special parallelogram. So remember, the opposite sides are congruent on a parallelogram. Opposite sides are congruent on parallelograms. Opposite angles are congruent on parallelograms. And diagonals bisect each other on a parallelogram. So these things are still true on special parallelograms also. Okay, so I want you to keep that in mind. So everything, if it's a parallelogram, these three things are always true. And they're if and only if statements like we talked about before. Now, when we're talking about a rhombus is a very special parallelogram. So what's the definition of a rhombus? A parallelogram is a rhombus if and only if all sides are congruent. Okay? So that's the definition of a parallelogram. A parallelogram is a rhombus if and only if all sides are congruent. So that's biconditional. So you could say again, you could also say if all sides on a parallelogram are congruent, then it's a rhombus. You could also say that. Now, we've kind of been hinting about this. Some of you have been you've known this. This has come up before. So if we have a rhombus, we're going to call this first one the let me go down. We won't do rectangle. Rhombus diagonals angle bisector theorem. Rhombus diagonals angle bisector theorem. So we're going to prove. So what does this say? It says the diagonals so let me say sorry guys. The diagonals on a parallelogram bisect each other. Bisect opposite angles if and only if the parallelogram is a rhombus. Okay, so let me say that again. Sorry, it took me a little. So the diagonals of a parallelogram bisect each other if and only if the opposite angles bisect. Okay, let me say this one more time. Sorry about that. The diagonals on a parallelogram bisect opposite angles if and only if the parallelogram is a rhombus. Okay, so if the parallelogram is a rhombus, then the diagonals bisect the opposite angles. If the diagonals on a parallelogram bisect the opposite angles, then the parallelogram is a rhombus. Okay, so let's take a look at why that's true. So if I draw a rhombus, let me see if I can draw a rhombus here. Hopefully my ink to shape will help me out. Okay, here's a rhombus, and I'm trying to make it not look like a square. So this is a non-square rhombus, which is fine. So the first thing, so we'll call this A, B, C, and D. And what we want to show here is we want to show if this is a rhombus, then the diagonals bisect each other, okay? Well, the easiest thing to do, and I'm not going to write this whole proof out. I'm just going to kind of show you why this is true. I'm just going to kind of do a kind of an informal proof here. So the first thing I'll do is I'll just look at one diagonal here. So I'll look at the diagonal DB. Now, since this is a rhombus, by definition, AD is congruent to AB, which is congruent to BC, which is congruent to DC. So by definition, a rhombus has 4 congruent sides. Okay, it's also a parallelogram, right? So what can I say now? Well, I know that DB is congruent to DB, right? So I can say that. So now what I can say is I can say that these two triangles, I'll call this triangle 1, is congruent to triangle 2, okay? And so what I can say now is using CPCTC, well, this angle here is congruent to this angle here. But I already knew that angle A is congruent to angle C because it's a parallelogram, because by definition, a rhombus is a parallelogram. But what I didn't know is that ADB, this angle here, is congruent to angle CDB. And that's because of CPCTC. These two triangles, triangle 1 and triangle 2, are congruent because of side, side, side. So now I know that these two angles here are congruent to each other. Okay, and actually I think they're equal to each other because they're the same angle being bisected, which means all these little parts. So I can say all this angle, this angle, this angle, and this angle are all congruent to each other. So the diagonals bisect the opposite angles on a rhombus. Now, we only bisected one pair of angles, but as we said before, we would repeat the same process with diagonal AC. If we do diagonal AC and got rid of diagonal DB, we would repeat the same process and show it's the same thing. So side, 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 CPCTC shows that the angles are bisectors of each other. Okay? So from now on, we can use the rhombus diagonals angle bisector. The diagonals bisect the angles on a rhombus. Okay. Another thing we know is, and I'm not going to do a proof on this one, guys. I'm just going to show you. It has a proof. I don't want to make this video too long. So if you have a rhombus, okay, you have this rhombus here. I'll make it rhombus C, and we'll call this rhombus A, B, C, D. And if I go down here like this, and I go down here like this, okay, and I actually think I can do this. So these two, and we'll call this A, B, C, D. We'll call this E in the middle. What this is saying is, oh, and let me say this: the diagonals of a parallelogram. Sorry about this, guys. The diagonals of a parallelogram are perpendicular. The diagonals of a parallelogram are perpendicular if and only if the parallelogram is a rhombus. Okay? So here's what it's saying. The diagonals of a parallelogram are perpendicular if and only if the parallelogram is a rhombus. Now, what am I trying to say here? I'm trying to say that, or you could also say if a parallelogram is a rhombus, then its diagonals are perpendicular to each other. So we're saying that these are all right angles in the middle. They're all intersecting each other perpendicular. Now, why would that be true? Well, you know that the diagonals on a parallelogram are perpendicular bisectors of each other, right? So they bisect each other. So and if we just look at, let's say, this top triangle right here, okay, we don't even look at the other ones. So what do we know here? Well, we know that we can use the perpendicular bisector theorem that says if a point is on the perpendicular bisector of an angle, then the point is equidistant. Well, we know the point is equidistant because it's a rhombus, right? So we know this is true, and we know this is true. Therefore, we know it has to be a right angle. Okay? So we have right angles. So rhombuses always intersect each other at right angles. They're diagonals. And now on. And I didn't really do a great proof with this. I said I was going to do a proof, but if you can kind of see the perpendicular bisector theorem there, okay, that's why it works. Okay? All right. And the last thing, the rectangle diagonals congruent theorem. Rectangle diagonals congruent theorem. Okay, so this is what this is saying. Here's what I would say. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Now, before we say that, I skipped to this a little bit. What is the definition of a rectangle? All right, a rectangle, if a parallelogram is a rectangle, then the parallelogram has all right angles. So that's the definition of a rectangle. It has all right angles. Okay, and then we are done. Okay, so what I want to do now is take a look at this. So if I go down here, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So what do we mean by rectangle? We mean a rectangle is a parallelogram with right angles. And so if this is rectangle A, B, C, and D, then diagonal AC is going to always be equal to diagonal DB. Now notice these diagonals don't have to be perpendicular. Okay, they don't have to be angle bisectors either, because as we're talking about a rectangle. Okay, we're not talking about a rhombus now, we're talking about a rectangle. So the only thing we know about rectangle and their diagonals is they always have to be congruent to each other. Now, squares, we don't talk a lot about squares because squares are just rhombuses and rectangles put together. So just think about a square as a rhombus and a rectangle all put together. All right. So what I want you to do now is just go ahead and look at your Delta Math and get that Delta Math going. I'm going to try to find some stuff on Delta Math that involves rhombuses and rectangles. So have a great day, and we'll see you later. Bye.